here. Let me just do it here. Okay, at the end of the question, I'm going to solve some word problems from review questions. As you know, at the end of each chapter, there's a review questions. That is mixed problems from that chapter, okay? So last time we were talking about some rules in algebra, right? Simplifying algebraic expressions and use of brackets and simplification. It means in simplifying algebraic expressions. And we did these examples, right? And also that example. So we stopped here, I think. So quickly, we'll just have a look at these examples. And after that, we'll talk about algebraic expressions with coefficients. Anyway, so actually, you know these things. Again, I'm just showing you one more time so that you understand when we actually say addition of algebraic expressions, so subtraction of algebraic expressions. As you know here, this is one algebraic expression, right? That is, what is it? Just letters multiplied by numbers, and after that they are added together, so they form algebraic expression because they are expressing something. How do you read this? Actually, this thing means A is multiplied by 2, B is multiplied by 3, and C is multiplied by -4, and we are just adding all the things together, right? And they form algebraic expression because we have letters here as called algebraic expression. If I just write here equal something, then they become algebraic equation. Anyway, so actually we have already studied that when we just say sum of something, we have to add those things, right? So it says find the sum of this and this and this and this, right? And let's say the sum is S, okay? So that means that we are adding these things together to A plus 3b minus 4c plus the second expression is 3a minus 2b okay, plus third expression is -4a plus 5c and plus a minus 2b plus c, right? We have just written what actually we have to do here. What is the next step here? What should I do in the first step here, Shahina?
I think you have to add the first, I forgot how to call it, but the first parentheses that's in the beginning.
Yeah, actually first we need to clear the brackets, right? This parentheses, right?
Oh yeah.
We have to clear them, and after that we need to add like terms. Actually, in front of all these parentheses, it is plus and plus and plus. It doesn't change anything. So if I do so, maybe you can do this thing mentally, but that is what we have to do in the next step. Sometimes when it is minus, you should be a bit more careful. So if we just remove the brackets to a plus, hello? Isn't episode ders zamanı mı? Hop hop. All right, sorry. 2a plus 3b here minus 4c. Also in front of this plus, so we don't have to change the sign, right? Actually, if we have minus here, at that time we need to change each sign of this term to the opposite sign, right? If it is minus, it becomes plus. If it is plus, it becomes minus. So it is plus, so we don't have the anything. Just write itself 3a minus 2b, and also here it is plus. So here we have plus minus, it is minus 4a plus plus is just plus 5c. And a similar way here we have a minus 2b plus c. So now we need to add or subtract things, right? To do this one, we need to find the like terms. So here, for example, a's, we have 2a. All right, here we have 3a. All right, here we have 4a, and here we have a. Good. So now I can do this 2a plus 3a. What is it?
5a.
5a. 5a minus 4a.
1a or a.
Just a. A plus a.
2a.
So here we have 2 times a. All of the things are gone, right? Okay. Next thing is b's. Here we have b, and here we have b. All right, and here we have b. Very good. 3b minus 2b. What is it?
b.
B, right? 3b minus 2b. It's just b. And b minus 2b. What is b minus 2b?
Negative 1b.
That's right. So here we have minus b, right? Good. Also, the things are gone. Now, what is left here? C. Here we have c, negative 4c, plus 5c. It is just c, right? And c plus c, it is 2c. Done. Right? It's so simple, but just you need to understand what we mean by sum. And these like terms, how to simplify, we have already studied. Here the main challenge is, can you do this fast? Okay, mentally, but can you just that thing adding or subtracting things, can you do fast? That is important thing here. Okay, now another example is, what is it? Subtract 3a plus 4b minus 2c minus 5d. That is one algebraic expression from 2a plus 5b minus d. So actually, a lot of students get confused. We need to subtract this thing from this, right? So that means that here we have 2a plus 5b minus d minus. So I have to subtract this expression from this, right? Minus 3a plus 4b minus 2c minus 5d. It is one expression. That's why actually always we need to put this in parentheses, right? Then if it is plus, we can just drop it. Otherwise, if it is minus, then accordingly we need to make some change in the signs of these coefficients. All right. The first step is we need to clear the brackets in front of this parenthesis. There's nothing. So here we have 2a plus 5b minus d. All right. And here we have minus. That means here we have negative 1 times 3, that is minus 3a, minus plus minus 4b, minus times minus plus 2c, minus times minus plus 5d. Now we can just add or subtract the like terms, right? Okay. So starting with 2a, do we have a here? Yes, here we have a. Anything? No. What is 2a minus 3a?
Negative a.
All right, very good. It's gone. And 5b. Here I have 5b, 5b minus 4b
1.
plus b, just b, right? Very good. And here I have negative d plus 5d minus d plus 5d. What is it?
60.
This is minus, this is plus, opposite signs, right? So we have to subtract. So here we have minus d plus 5d. That means that what is negative 1 plus 5 is equal to 4, right? So here we have plus 4d. Okay. Still, we have not done yet, right? We have one more thing, but only C we have here. We do not have any other like terms. So just write here plus 2C. Maybe actually I should write here better because it should be in alphabetical order, but it's fine. Okay. Shahina, I will open new slides. All right. That much is enough for here. You need to practice other questions yourself. Okay. All right. Are you there?
Yeah.
Okay. Now we are going to learn again similar thing, but now this time the coefficients are fractions, not the whole numbers or integers. Okay, you know that when we say integers, we mean this z, the set of integers. What are the integers? That is like -3, -2, -1, 0, 1, 2, 3. These are the integers, right? And how about the rational numbers or fractions? Actually, rational number, usually we use Q. Okay, it is a number which can be written in this form where A is integer and also B is integer. We have one condition that B is not equal to 0. That means that any number which can be written in this form A over B, we call this rational number, right? Rational number means just a fraction. Okay, these numbers you can see this. How about rational number? It means that like in a set form, if this thing is, let's say this thing is the folder that contains all the integers here, right? And here we have this rational numbers that is bigger than this. That is bigger than this. Also actually it contains all the integers. That is the set of, what is it? Rational numbers. Because every integer is rational number, but not every integer is, not every rational number is integer, right? Because for rational numbers, for example, 3 over 1, actually this is equal to 3, right? 3, I can write it as 3 over 1. So that is a rational number. And how about 2 over 3? Rational number, it's a fraction. So minus 1 over 2, rational number. And here we have 10 over 2. These are all rational numbers. Okay, so here, if you just take one algebraic fraction here, for example, 2x minus 3 over 4. What is it? This is algebraic fraction. Why we call this algebraic fraction? Because if any fraction involves or contains any letter, we call this algebraic fraction. Because algebra means it's a branch of math that deals with variables, right? So as you see here in the numerator, I have variable here, x. That's why we call this algebraic fraction. This thing, I can do some manipulation on this. I can write it as 1 over 4 times 2x minus 3, right? Actually, I'm just writing here 2x minus 3 over 1. Because if you remember, how do you multiply two fractions? A over b times c over d. To multiply two fractions, we should multiply numerator by numerator, denominator by denominator, right? That is a times c over b times d. And also the same thing here, like this. Here we have fraction, right? 1 over 4, because I can write it as 1 times 2x minus 3, and this one is 2x minus 3 over 1. Because 1 times 2x minus 3, it is 2x minus 3. 4 times 1 is equal to 4. That's why I can write this fraction as this. Or if you just write this in this form, 1 over 4 to x minus 3. Now remove the brackets. What do we get here? 1 over 4 times 2, that is 2 over 4. That's actually 1 over 2. Here we have x minus 1 over 4 times 3, that is 3 over 4. That means that I can write this fraction, this algebraic fraction, either this way or this way or this way. They all actually, all these algebraic fractions are equivalent to each other. They are the same thing, right? Okay, that's what we are going to do here, because if you are given algebraic fractions, now we are going to add them and subtract them together. Okay, let's start with the first one. So simplify the following expressions. If I start with this, a, right? So 2x minus 3 over 5 plus x minus 3 over 3. Hey, Shahina, how can we add these two fractions together? What is the first step we have to do here?
Find the common denominator.
Very good. We need to find the common denominator, right? And also you can find this easily. That means that least common multiple of 5 and 3. What is it? It is 15, right? So actually I can write it as multiplied by 3 because also I'm using this property of the fraction. If you're given fraction a over b, if you multiply its numerator and the denominator by the same number, the value of the fraction does not change, right? Using this property, here I'm going to multiply numerator by 3, and here 5, 5. So if you multiply numerator by 3, what do we have here? 6x minus 9 over, if we have 15, plus multiply by 5, 5x minus 15 over, if we have 15. So we have the same denominators. I can write under the same fraction, fraction line, 6x plus 5x, that is 11x, right? Negative 9 plus negative 15, that is negative 24, right? So we have expressed these algebraic fractions as a single fraction. Okay? B, here we have 3 and 9. What is the common denominator?
18.
18?
Yes.
What is the least common multiple of 3 and 9? Is equal to 9, right?
Oh, true, I forgot.
Yeah, so common denominator here is 9. Also, you can actually multiply by 18, doesn't matter, but it becomes more complicated. You know, always we should keep our expressions in the simplest form. So multiply this fraction, numerator and denominator by, what is it? 3. So multiply by 3, here I have 6x minus 7 over 3, here we have 9, minus 2x minus 6 over 9. We have unwanted line. Good. Denominators are the same, but when we have minus here, you should be careful. A lot of students make a mistake when there's a minus. They multiply this term by this, but they forget to multiply this by this. But this minus belongs to each. Because this thing means here we have something like this, right? 6x minus 7 minus, here I have 2x minus 6. We have something like this, right? So now if you remove the brackets, 6x minus 7 minus times 2x, that is minus 2x minus times minus 6 plus 6 over, what we have here, 9. Okay, now we can simplify this. We know how to simplify this kind of expression, right? 6x minus 2x, that is 4x, negative 7 plus 6. What is it?
Negative 7 plus 6 is negative 1.
Negative 1. So here we have negative 1 over 9. Okay. So we have expressed the given fractions or algebraic fractions as a single algebraic fraction. All right, C, let's do C now. How about C? 2, 5, 6. What is the least common multiple of 2, 5, 6? What is it? Not 5. 5 times 2, 10, not 10. 15, no. 20, no. 25, no. 30. Right? 30 is divisible by 2, by 5, by 6. So least common multiple of 2, 5, 6 is 30. So here I need to get 30 here. The first one to get 30, we should multiply by 15, right? So multiply numerator and denominator by 15. What we have here? 15x plus 15y, right? And let me just write here, plus here we should multiply by 6. 6 times 3, 18x, minus 6 times y, it is 6y, right? Minus, now here multiply by 5. So here we have 35, 2x minus 4. And here we have a long fractional line. Here we have 30, right? Equals, I need to write one more time. Actually, I can write this 30 like the previous one. As you see here, I can just write it like this, right? Sometimes to actually write them in simpler form, I can just write 1 over 30 out. So here we have 1 over 30 times. I have the whole expression here. Here I have 15x plus 15y plus, here we have just plus, we don't have to change anything, 18x minus 6y, but here we have negative, right? Negative 35 times 2 minus 70x minus plus, what is 4 times 35?
Let me see. 100.
140. 35 times 4.
Oh.
35 times 4.
140.
Very good. Here we have 140, right? So now we should simplify this. Let me try to write the answer here. Equals, and the small fraction in the denominator we have 30, right? 15x plus 18x. What is it?
That's gonna be.
So here we have 15x, and here we have 18x, and here we have negative 70x, right? First, 15 plus 18.
33.
33. 33 minus 70.
That's gonna be 50. Negative 50x.
Minus 37.
Oh,
Right?
I see.
Because here we have 33 minus 70. This 70 is greater, the sign is minus, so it will be minus. So we have to subtract, because it is plus, it is minus, right? 70 minus 33, it is 37. Because 30 plus 30, it is 60. 3 plus 7, it is 10. 60 plus 10 is 7, right?
Mm-hmm.
So it is 37. So here we have 37x. So with this x terms, we are done. Now here we have 15y. 15y minus 6y. What is 15y minus 6y?
9y.
Plus 9y. Very good. And how a constant? We do not have any constant, only here, right? That is 140. So here we have plus 140. Okay? So we have simplified the given algebraic fractions and expressed them as a single algebraic fraction. Minus 37x plus 9y plus 140 over 30. Okay?
Mm-hmm.
Shahina, did you get your Wacom tablets? Or
Yeah.
not yet?
It's right here.
Did you use it or not yet?
A couple times.
Okay. All right. So now we will talk about factorization. Okay. So factorization is just reverse operation of, what is it? Expansion. You know, before now, in a lot of examples, the question was starting with expand the expression, expand and blah, blah, right? So now we will learn about factorization. What is factorization? Factorization is writing an algebraic expression as a product of two or more algebraic expressions, usually simpler algebraic fractions. So which are called the factors. Each one is called the factor, right? And like, for example, when you talk studying primary school, and also you learn how to do prime factorization of numbers, right? Prime factorization. If you remember, let me just write here, prime numbers. What is a prime number, Shahina? Do you know? Do you remember?
Is that like, it's a number that doesn't have any like can't be multiplied more than one, I think. What was that?
Okay. Prime number is a natural number which has exactly two different divisors or factors. That's the definition of prime number. So it's a natural number which has exactly two different or two distinct factors. Okay, that's the prime number. What numbers have exactly two different factors, like 2? What are the factors of 2? 1 and 2, right? It's divisible by 1 and 2. Another one is 3. 1 and 3. 5. 1 and 5. 7. 1 and 7. 11. 1 and 11. 13. 17. 19. 23, right? And 29. 31. 37. These are the prime numbers. Okay. For example, the question asked in a lot of cases, how about 1? Why 1 is not a prime number?
Because you can multiply one by anything, like
Because 1 has only one factor. It is 1. That's why. To be a prime factor, it must have exactly two different factors. Okay, that's why. All of these numbers, they have exactly two different factors, right? What are these? 1 and 2, they are different. 1 and 3, they are different. 1 and 5, they are different. Like if you take 4, for example, it's not a prime number because what are the factors of 4? That is 1, 2, 4. It has 3 factors, more than 2. Like how about 6? It has factors 1, 2, 3, 6. More than 2, right? That's why it is not a prime number. Okay, now let's get back to our prime factorization. What do we mean by prime factorization? Prime factorization means writing a natural number or any integer as a product of prime numbers. It is really important in math. That's why it has a special name, prime factorization. Like for example, let's say 12. Can you write it as a product of only prime numbers? Yes, it is 2 times 2 times 3. Is 2 prime number? Yes, right? How about this 2? Yes. How about 3? Prime number. So I have written here 12 as a product of prime numbers only. That's why this process is called prime factorization in math. And how about 20, for example? Can I write this 20 as a product of prime numbers? Yes, it is 2 times 2 times 5, right? 2 is prime number, prime number, prime number, right? That's all. Because every number has only one. Actually, we can, yes? Yes? Yeah, give me a minute. Huh? Huh? Mom. Cow. Okay, mom. Shahina, I'm sorry.
It's okay.
Yeah, one guy was trying to enter our university. That's why security guards came to me and asked if we allow him or not. And that's why I had to go downstairs. Okay. So we were talking about prime factorization. Okay. And actually the same thing we are going to do with algebraic expressions. Now you will see not numbers, but algebraic expressions. Like if you remember, for example, 3x plus 6, right? For example, here, what we did here before, when we are given like this, 3x plus 2, if they say expand this, what we did here is we need to clear the brackets, right? 3 times x, 3x plus 6, okay? Now this way. So now we are going to do how to do this in reverse direction. All right, like this. If I'm given here, how can I change this into this form? That means that how can I write this expression as a product of two or more algebra expressions? That means that here we need to find the common factor, right? This thing is 3 times x, and this thing is 3 times 2. Common factor is 3. I can take this out, right? And here we have x plus 2. Okay. But this is really important in math because a lot of now, soon we will start learning or studying solving algebraic equations. When we are solving algebraic equations, this thing is really important. We have to factorize and after the solve this, okay? For example, let's see these examples. Factorize the following. Factorize means write the given algebraic expressions as a product of two or more algebraic expressions. It means this. For example, in A, 5x minus 15. I have only two terms. The only way to factorize this, I have to find a common factor and take this out, right? So here we have 5 times x minus, how about 15? I can write it as 5 times 3. So that's a common factor here, 5. Take this out. So here we have x minus 3. So as you see here, I have one algebra expression. Now I have here two things. I wrote this thing as something times something, right? That is called factorization. B, for example, let's say here we have 3ax plus 12ay, right? I can write this 3ax, 3a times x plus, how about this 12y? We can write it as 3a times 4y, right? Because if you simplify here, 3 times 4, it is 12, right? And a times y, it is ay. So now I can see the common factor. This is a common factor. So take this out, 3a. So here what we have here, x. And how about here we have 4y. Okay, what we did here is we have factorized the given algebraic expression. And how about C? C is just D, is a D, common factor. So here we have x plus y plus z. Okay? Continue. How do you factorize these things? Okay. As you see here now, instead of one letter, we have an expression here. 2x plus 3 and the 2x plus 3, right? If I just, let's say this a is equal to 2x plus 3. At the time, what we have here, then here we have h times a plus here we have 2 times a, right? If you just take this a out, what we have here? A, h plus 2. Now, instead of a, I can write it as expression here because a is this thing. So since it is algebraic expression, I need to write in parentheses because it's multiplied here. So here we have 2x plus 1. And here we have, what is it? H plus 2. H plus 2. You see, actually, we are using the same idea also here. So here we have 2x plus 3. It's a common factor. Take this out. 2x plus 3 times. And what is that here? We have h and plus 2. Plus 2. So we have written this sum, right, as a product of two algebraic fractions. Not fractions, expressions. How about here equals, as you see here, 5x plus 2, 5x plus 2. The same thing, that's a common factor. So take this out. So what do we have here? 5x plus 2. And here we have 2h minus, what do we have here?
5x plus 2.
5x plus 2. If we just extract this, right? Now here 2h left, so 2h. Here we have minus, we have minus. Now what is left here? If I just take this out, what is left here?
Wait, sorry, can you repeat that?
1, right? It is 1. Because here
yeah.
nothing means here we have something. 1 times this thing. Okay, some students actually they just put 0. We don't have 0 here. If we have 0, 0 times anything equals 0. Here we have 1. That's why when this is 1 in algebra, as you know, 1 times a, we don't write this 1. We just write a, right? Or 3x plus 1 is the same thing as 1 times 3x plus 1. Okay. Good. Shahina, now can you do this? Tell me, what should I write? Or if you have tablet, can you just show me how to do this? Is it connected?
No. I mean, I don't know. Like, I have to still get used to it, but I guess I can try.
Okay, try it. Can you just connect also? Did you install the driver?
Yeah, I have.
Okay, now it's ready to use, right?
Yes.
Okay, just connect and you will see your pencil. Can you write here? How do you do this question?
Okay. Wait, can you see the screen or?
Can you just write something on the screen?
I don't know, like, it's like moving as the mouse.
Okay, write it. Put on the Wacom and write it.
It won't write anything like when I try to press it.
Oh. So show me your pencil.
Hold on. It's this.
Okay, did you just choose a pencil here? You see here, I'm just clicking this, right? Here we have laser pointer, pen, highlighter, eraser. Did you choose pen here?
I don't have that there. It's just
Or,
a normal.
yeah, pencil, there's a small button, right? Can you just click it and you will see? Put
Which
it,
one?
yeah, here, the small one. Yeah, just click. No, but you need to keep this, the tip of the pencil on the tablet first.
Okay, let me see. Yeah, I still don't see it.
So you don't say, I think you didn't install the driver. Did you install the driver or not?
I don't know. I don't think so.
Okay. Then I'll tell your father, he will do it for you, okay? Because first you need to install this driver. If you just write Wacom driver in Google, okay, after the class, not now, and it will just show this, and they will ask your Wacom model. If you just enter the Wacom model, immediately it shows the driver you have to install, then you can use it. Okay, no problem. Shahina, next time, okay, tell your father that you have to install this driver first, then you can use it like me. So you can write anything on the screen. Okay? Hello? Okay, Shahina, let's continue. As you see here, also 2y minus z, 2y minus z, right? And it's a common factor here. That means that what we are trying to do here is you should be able to see that here we have something like this: a times x plus b times x, right? So this x is a common factor. I'm just extracting this. What is that here? A plus b. Our x here is this expression, not a single thing. So just take this out, 2y minus z times, and here we have, what is that here? 3a. It is 3a plus 4b, plus 4b. Okay. In similar way, in the last example, here we have, as you see, these things are the same. It's like a times x minus b times x. So if you just take this out, what we have here? 2a plus b minus 3c times what we have here? 5x. 5x minus 6y. Minus 6y. Okay? Okay, Shahina, now I'll give you a break, okay? 10 minutes. After 10 minutes, we will continue. We will have our second session, okay? Have some break and have some rest.
Okay.